Welcome to online classes. Today we will discuss system of linear equations and its solution by matrix method. So first of all, we have to discuss what is system of linear equations. Suppose let a1x plus b1y is equal to suppose c1. Okay, and another equation. Suppose a2x plus b2y is equal to c2. So we take two linear equations and having two variables, that is x and y. Now the two equations have to represent in matrix form. So here we can take let suppose a is equal to a1 b1 a2 b2 and b is equal to, suppose we take b is suppose we have take x is a variable, that is x and y, and suppose another take let b, that is c1 c2. Okay, so here if the two equations we have to take let a is a matrix form, that is the coefficient of x and y, and x is the variables and b is constant. So now we have to multiply a into x. If we multiply a into x, so here the value of a is the matrix of a1 b1 a2 b2 into the value of x is x1. So first of all, we have to multiply two matrices. First, we have to check is it possible to multiply them or not. So here, the order of the first matrix is 2 into 2, and the order of the second matrix, that is 2 into 1. As you know in previous session, how to multiply two matrices. As you see, number of columns in first matrix is 2. And the number of rows in second matrix is also 2. So here both are same, so we have multiply. Okay. So here if we multiply and the result will be first and last, that is 2 into 1. So 2 into 1 means, that means 2 rows and 1 columns. Okay. 2 rows and 1 column. So this is the position of 1, that is first row and first column. So if we multiply them, then we get a1x plus b1y, and another, this is the position of a21, so second row first column. That means if we multiply, that is a2x plus b2y. Okay, so if we put the value of a1x plus b1, as you see in first equation, a1x plus b1y is equal to c1. So if we put the value of this, then that is c1, and if we put the a2x plus b2y, that is c2, and that is c2. So here we get matrix of c1 c2, and the c1 of c2 is equal to. So the system of linear equation we have to represent that ax is equal to b. So this is the representatives in matrix form. Okay. So here the formula is ax is equal to b. If we find the value of x, that is equal to x is equal to a inverse b. So that is the formula to solve or the solution of system of linear equation by matrix method. Okay. So this is the very, very important part in unit 2, and it is a long question category. So here x is equal to inverse of a into b. So this is the formula. This is a very important formula to evaluate to get system of linear equation by matrix method. So now take let examples. So this is the formula that we have to evaluate Now we take an examples here. Find the or solve, we can say solve 2x minus y is equal to 5 and 3x plus 2y is equal to 1. So solve 2x minus y is equal to 5 and 3x plus 2y is equal to 1 by matrix method. In previous classes, the same form or same system we can solve by Cramer's rule, but today we learn solve this system of linear equations by matrix method. Okay, so how to solve them? Here is the solution. First, we have to write the simultaneous linear equation in a systematic order. That means first we have to write 2x minus y is equal to 4. That means we have to first write first x, then y, and then right side constant. So here 2x minus y is equal to 5, and the second part, that is 3x plus 2y is equal to 1. Okay, so this is the system. You can say the system of linear equation because it contains two variables and two equations. So the system is in the form ax is equal to b, but we have to find the value of x, that is a inverse of b. So this is the formula that we have to evaluate, that the x equal to a inverse of b. So here the value of a is equal to 2 minus 1, because value of a is the coefficient of x and y, that is 2 minus 1, 3, 2, and the value of x is equal to, because x is the variable, that is xy, and the constant b is equal to 5, 1. So here a is equal to the matrix of 2 minus 1, 3, 2, and x equal to variable, that is xy, and b is equal to 5, 1. Okay. So first of all, that we have to evaluate a inverse of b. X is equal to a inverse of b. That means inverse of a. In previous classes, how to evaluate inverse of a? Inverse of a is the formula 1 by determinant of a into adjoint of a. So that is the formula of a inverse of a. So first of all, we have to evaluate determinant of a, then adjoint of a, and then multiply to get the value of x. So here first we have to find the determinant of a. So here 2 minus 1, 3, 2. If we evaluate this second row determinant, that is 4 minus of minus 3, that is plus 3, that is 7, and which is not equal to 0. First of all, we have to check, is it determinant of a is 0 or not. If determinant of a is 0, then we cannot determine the equation. Okay, but here you can see determinant of a is not equal to 0, that is 7. So first, then adjoint of a. So adjoint of a means we have to first evaluate minor, then couple, then adjoint. So there are 4 number or 4 elements. So this is the 4 number, and we have to first evaluate minor. That is first is m11. So m11 means this is the value. If we evaluated, then we get 2. Okay, and the value of m12. If we deleting these values, this is the position of m12. Okay, if we deleting this value, then we get 3. Similarly, m21, that is m21, this is 3, this position of 3. If we deleting this value, that we get -1, and the last one is m22. So the value of m22 is 2. Okay. So this is the minor of these elements. Then you find cofactor. Okay. So the value of C11 means if we add them, if we odd, then we can write the sign, change the sign of the value. If we add them, we get even, then we can write the same value. Okay. So here you can see you can write 2 because 1 and 1, that is 2, and 2 is an even number. So we can write the same value of minor. And the C12 value is changes the sign because if we add them 1 and 2, that is 3, and 3 is an odd number. So we change the value. Value means sign of the, okay. And the third one is MC21, that is +1, and the last one is 2. So this is the minor and cofactor, and then we have to find adjoint of A. And the adjoint of A is, as we know in previous classes, how to evaluate adjoint of A. First two values you can write directly. First two values is the first column, that is 2 minus 3, and the second two value is 1, 2, and the second column. Okay. So this is the adjoint of A. Okay. Now, as you see, the formula is x is equal to 1 by determinant of A into adjoint of A into B. So here all the values we have to found in determinant of A, adjoint of A, and the value of B is also here. So next we have to find, now as you know, x is equal to A inverse of B. So inverse of A is, formula of inverse of A is 1 by determinant of A into adjoint of A into B. So if we put the value of determinant of A, and the determinant of A is, I think that is 7, into adjoint of A is 2, 1 minus 3, 2 into B. Value of B is 5, 1. Okay. So if here we have to multiply them. First we have to multiply matrix to matrix. So here you can see this is the order of 2 into 2, and this is the order of 2 into 1. So here the multiplication and the order must be 2 into 1. So here this is the question. That means first row and first column we will multiply, then we get 10 plus 1, and that is minus 15 plus 2. Okay. So that is 11, and that is minus 13. If we multiply this scalar, that is 1 by 7, then we get 11 by 7, and another is minus 13 by 7. So that is the value of x, and the value of x is xy, determinant of xy. So if we compare in equality matrix, then we get x is equal to 11 by 7 and y is equal to minus 13 by 7. So this is the solution of the variable x and y of the given system. If we put, how to check the answer is correct or not? If we put the value of x and y, then you get the value of the right side. Okay. Now we have to check that it's correct or not. So here we have 2 into x minus y. If we put the value of x, that is 11 by 7 minus y, that value is minus 13 by 7. That means plus 13 by 7. Okay. So here the LCM 7, 22 plus 13, that is 35 by 7, and you get 5. So here the value is also 5. Similarly, if we put the value of the second one, then we get 1. So this is the correct answer. We evaluate the system of the given system by matrix method. Now we let another examples in 3 variables, and that is the long distance category. So let's start. Solve this system by matrix method. Suppose x plus 2y plus 3z is equal to 8. So here we take 3 variables. Then the second one is 2x plus y plus z is equal to 8. And the third one is x plus 2z plus y. X plus 2z plus y is equal to 6. So here solve the given system by matrix method. And it is a long distance category problem. So look at the system first. X plus 2y plus 3z equal to 8. The second equation is 2x plus y plus z is equal to 8. And third one is x plus 2z plus y is equal to 6. So first of all we have to write in a systematical order. That means first equation is x plus 2y plus 3z is equal to 8. And the second one is 2x plus y plus z is equal to 8. And this is also a systematical order to write. So the third one is x plus y. Then we can write 2z. Because you can see here x plus 2z plus y, you have to write in a systematical order, that is first x, y and then z. So here x plus y plus 2z is equal to 6. First of all, we have to write in a systematical order. Okay. So here the system, you can see the system is in the form ax is equal to b and the value of x is equal to a inverse of b. Okay. So this is the formula to evaluate the value of x by matrix method. So here first we have to find the value of a in a matrix form, that is a is the coefficient of the variable, that is x, y, z, and the coefficients are 1, 2, 3, 2, 1, 1, 1, 1, 2, and the x is equal to the variable, that is x, y, z, and the value b is equal to, because b is the constant which is in the right side of the equations, so that is 8, 8, 6. So first we have write ax b. So first of all we have to calculate or evaluate determinant of a. First we have to check determinant of a is equal to 0 or not. If equal to 0, then we cannot determine this value, the equation. Okay. So determinant of a in the determinant form, so we can write 1, 2, 3, 2, 1, 1, 1, 1, 2. So if we evaluate, then we get 1 into 2 minus 1, minus 2 into 4 minus 1, plus 3 into 2 minus 1. Okay. So if we calculate that 2 minus 1, that is 1, 1 into 1, 1. 4 minus 1, that is 3, 3 into minus 2, that is minus 6. 2 minus 1, that is 1 into 3, that is plus 3. Okay. So if we calculate, then we get minus 2. Okay. And which is not equal to 0. If determinant of a is not equal to 0, then we can evaluate this system by matrix method. So now we have to evaluate minor. So this here you can see 9 elements, so 9 minors. Okay, so M11, M12, M13, M21, M22, M23, M31, M32, and the last one is M33. Okay. So first of all, we have to calculate or evaluate minors. So M11 means the value of this element, that is 1. If we delete this element, then we get 1, 1, 1, 2. If we determine, then we can 2 minus 1, that is 1. So we can write M11 is 1. Okay. Similarly, M12, this is the value of M12. If you delete this value, that is 4 minus 1. 4 minus 1, that is 3. And the third one is M13. That is the value of M13. If you delete this value, that is 2 minus 1. That is 1. M21 is the value of M21. If you delete it, then 4 minus 3. That is 1. M22. This is the position of M122. If you delete it, then 2 minus 3. That is minus 1. M23. This is the value of M23. If you delete these values, then 1 minus 2, that is minus 1. M31, this is the position. If you delete it, then 2 minus 3. 2 minus 3, that is minus 1. M32, M232. If you delete these values, 32, this is the position. If you delete it, then it is 1 minus 6, minus 5. And the last one, M33, 33, then y get 1 minus 4, minus 3. So these are the minor of the given elements. Now we have to find cofactors: C11, C12, C13, C21, C22, C23, and here we can write C31, C32, and the last one is C3. Okay. So C11, the value of C11 is 1. This changes the sign because minus 3, 1, minus 1, minus 1, 1. H31 is minus 1, and 32 is 5, and the last one is minus 3. So these are the cofactor of the systems. So now we have to evaluate, we have to write adjoint of A. So adjoint of A is the first 3 element, first column, that is 1 minus 3, 1. And the second 3 elements, that is minus 1, minus 1, 1. Minus 1, minus 1, 1. And the last 3 one is in third column, that is minus 1, 5, 3. Minus 1, 5, minus 3, sorry. Minus 1, 5, minus 3. So this is the adjoint of A. Now, as you know, the formula of x, that is x is equal to A inverse of B. So inverse of A, the value of inverse of A is equal to 1 by determinant of A into adjoint of A into the value of B. So now we have to put the values, that is determinant of A is 1 by determinant of A is minus 2 into adjoint of A, the adjoint of A is 1 minus 1 minus 1 minus 3 minus 1 5 1 1 minus 3, and the value of B is 886. So we have to evaluate them, that means we have to multiply them, then we can fill it. So first of all, we have to multiply matrix to matrix. As you see, the order of the first matrix is 3 into 3 and the second one is 3 into 1. So it is possible to multiply them because the number of column of first matrix is the same to the number of row in the second matrix. So is it possible? So here the order of the result matrix is 3 into 1 because the first value is 3 and the last one is 3. So the result matrix must be 3 into 1. 3 into 1 means third row and 1 columns. So this is the positions. So this is the position of 1 1, that means first row and first column. If we multiply them, that is 1 into 8, that is 8, minus 1 into 8, that is minus 8, plus minus 1 into 6, that is minus 6. Okay. And the second one is minus 24, minus 8, and that is plus 30. And third one is 8 plus 8 minus 18. So if we calculate them, 1 by minus 2 into, if we relating the values 8, 8, plus minus, then we get minus 6, and if we minus 32, 30, minus 2, and the last one is 16 minus 18, that is minus 2. So if we multiply the scalar multiplication, that is 1 by minus 2, then we get 3, 1, 1. So this is the value of x, and the value of x is x, y, z. So if we compare these matrix, then we get x is equal to 3, y is equal to 1, and z is equal to 1. So this is the solution of the system by matrix method. Now we have to check that it is true or not, the answer. So the answer is 3, 1, 1. So if we put the value of 3, that is x, 3. So first equation is x plus 2y plus 3z. Now you have to check them. So the value of x is 3. So if we put it, then we get 3 plus 2 plus 3, then it is 8. So the answer is 8. So this is the procedure to check them is true or not. So this is the procedure to solve by matrix method. So I think you all understand clearly. Have a nice day. Thank you.